So crazy story, right? A month ago, I was a dude in a garage with a camera talking about this crazy open source car project. And here we are 30 days later, we have 22 developers in the Discord channel, many of whom are accomplished engineers and talented designers, students looking to learn, and all people that I have personally talked to and placed in the channel so that we can develop together. The channel has been private up until today, at which point I'll be making it public, but hold your horses. We'll get into that a little bit later because I have a lot of cool stuff that I want to share with you in this video. So let's get right into it. So the first order of business is the idea that generated both the most love and the most hate, which is to be expected because we're talking about the rotary engine, specifically this intermediate housing that I want to make into a reluctance machine. So let's talk about that for a minute. Let's talk about choices, right? So in this development process, there's many choices that we're gonna have to make and compromises we're gonna have to make. We wanna always pick the best path forward with the resources we have available to us. And for me, right now, that's very limited resources, which is why we're starting with this rotary engine to begin with, because it was a non-essential engine that I had lying around that was running and in good shape. But it might turn out to be a blessing because there's some pretty cool advantages to the rotary engine, namely its size and power to weight ratio. So before I get into all the technical details of the design that I intend for this machine, I want to let you guys know that we're not actually going to be performing this experiment ourselves for this Project OSAKI. I'm sorry to tell you that, especially those of you who are really excited about this particular project, but I do have good news for you. There is a race team in Belgium called Giselle Racing. They love the idea of this project and they want to build a prototype themselves. And we're going to help them do it. So I am going to show you and them what I intend to do to engineer this thing. And we're going to cover their experiments and experiences as they build their prototype of this intermediate crazy radial flux motor monstrosity. The reason I'm not going to do it for Project OSAKI is because there's just a huge heat issue, and I don't think it's going to be the best use of my time since the focus is on price and economy. This is going to be an expensive project to perform all in itself, and when it's all done, it's not going to be a cheap engine to put in a car. So it kind of defeats the purpose of what we're trying to do, which is build something affordable. But for a race team, it's a perfect project. More power, crazy experiments, get to learn a bunch of cool stuff. I think it's a perfect fit for you guys at Giselle Racing, and I'm really excited that you reached out to me. And yeah, I'm happy to build this thing with you, help out any way I can. All right, so here's our intermediate housing. It's iron, which is bad for flux. This would be better if it was aluminum, which I think they're planning to do, which is awesome. Because what happens is when you have the iron on the outside, or all about in the case that it is right now, it's going to mess with the flux path and you're not going to get a lot of torque into the rotor because the magnetic flux is going to want to go through the housing rather than the rotor, and it's not going to produce much torque by doing that. So if this was all aluminum, it'd be much better. Short of that, I pictured cutting this whole center section out because there is oil that goes through the inside of here. You have oil galleys and oil sloshing around and oil being sprayed from the eccentric shaft into the center of the rotor as it rotates. And you have water going along the outside of this. Now, there are certain places you can cut and certain places you can't. And by trying to introduce 4 stator cores into the housing itself, you're producing a lot of possibilities for leaks, oil leaks and water leaks, water into oil, oil into water, yada, yada, yada. You get the picture. So I pictured cutting this whole center section out and replacing it with like a magnetic stator assembly with aluminum on each side and your stator cores, kind of where the Sharpie marks are here that you can see. So I am going to draw up a quick little CAD file and give you a better visual representation of what I'm talking about. All right, guys, here's our intermediate housing. We have North Pole magnets on one side, South Pole magnets on the other side. These are electromagnets, obviously. They're not permanent magnets. And let's bring up some rotors so we could see how they work. 1 rotor, 2 rotor, 3 rotor, party. Okay, enough of that. So as the top and bottom stator cores activate, the rotor will be in this position. So at 12 o'clock and 6 o'clock, the North Pole will go through the rotor, through the eccentric shaft, and then back out of the other rotor on the opposite side to the South Pole at the bottom. So the top and bottom will be in series, and the left to right cores will be in series as well. And those will activate as the rotor rotates a little bit to line itself up with those. It'll be the same type of configuration. Heat's going to be a big issue with this, so let me make these invisible again. So we can go in here. This is all hollow. This is an oil bath on the inside of here. I think we should have oil squirters pointing at all of the different stator cores to try to at least keep them as cool as the oil is, and just constantly keep spraying them with an oil bath because they're going to produce some heat. Yeah, it's heat's going to be an insane challenge. You'll probably need quite a hefty oil cooling setup in order to keep this engine cool. One potential good thing, I don't know how much of a good thing it really is, but one of the problems with rotary engines is they're mostly only hot on one side because they have all the exhaust is happening down here and all the intakes happening up here. So the top half of the housing is a lot cooler than the bottom half of the housing. So being as you're going to be pouring so much heat into the center housing, you'll kind of more evenly distribute the heat through the engine possibly. I don't know if that'll lead to any benefit. Usually more heat is a bad thing in all cases, but it's something to think about, I guess. I'm not smart enough to know what kind of implications that might have with the heat being more evenly distributed, but it'll be an interesting test. So you might be wondering, Warner, dude, if you're not going to build the hybrid rotary engine that you were gonna, whatever will you do? We are going to build a hybrid rotary engine, and that is why I've loaded up my wife's baby blue Bug with a bunch of rotary junk for measurement purposes. We're going to drive it 5 hours away and meet one of our valuable contributors on the development team. Bring this eccentric shaft over to him, cut it in half. I'm going to take this extra lobe off so that it's not spinning all that unnecessary weight. We're going to take our bearing surface, move it down to somewhere in here so we can eliminate the intermediate housing and the second rotor housing, and remove 3 combustion chambers and save fuel in the process, along with a bunch of extra weight. Then we're going to take the electric motor, an external electric motor of known performance values, put it on the outside, and get our hybrid assist that way. All right, so it's late. I have a long drive ahead of me tomorrow. If you haven't noticed, we have new Project OSAKI t-shirts available. Download reliablecar.zip, Project OSAKI in the back. Wonderful conversation starter for your friends so you can share the project with them. Hopefully they can get involved too. Check out the shirt while I rest. And first thing in the morning, we're going to drive 5 hours out to Arizona and ruin a perfectly good engine in the name of science. All right, folks, allow me to introduce you to the former Global Vice President of Engineering at GKN Aerospace and more recently, the Director of Engineering at Nikola Motor Company, Mark Bunyan.
Yeah, well, that's me.
Nice to meet you. It's good to finally put a name to the face.
Absolutely. No, it's great to see you.
So what would make a person as reputable and having as many accolades as you do be interested in such a silly project as mine?
Well, the thing that you've got in your hand, so I've been working on a DIY project to form metals and plastics with a little desktop machine. When I saw you make this, I thought, this could be a product. So this project looked like fun, and so far, the team has just been amazing. The amount of interest has been phenomenal. The amount of support and interest from everybody has been great. So I'm glad to get my hands on this.
This composite sheet that Mark has in his hand is part of an experiment that I'm performing, of which I already have a video out on the topic. Check up in the corner if you want to learn more about that. And I will be continuing to produce some developments in this area because I think this could potentially be a good candidate for how we're going to make the body panels for Project OSAKI. So what do you say we get the rotary junk out of the car and see if we can either ruin it or maybe make it better?
Okay, let's give it a go.
So here we have all of our rotary components laid out on the table. I had planned to take this eccentric shaft here, and Mark and I were going to turn it down on his lathe, but we got to talking and we got to assembling and theorizing and spinning around this little Dorito-shaped triple combustion chamber, and this is what we came up with. I came over here with the full intention of ruining this perfectly good eccentric shaft in the name of science, and thankfully we had a smart person in the room and he's convinced me otherwise. So instead of doing all this machining and taking off a huge lobe, trying to recreate the taper down here so that we can eliminate the intermediate shaft and the second rotor housing, and then do these threads and this woodruff key slot. Instead of doing all that stuff, which would take forever, and we don't currently have the tooling required to do it, and it would probably still need a second machine shop to do the final pass on the bearing surfaces, we're just going to put it back together the way it was with one of the rotors disabled. So you'll just have to pretend that there's a second rotor in place. I forgot to bring the other one with me. And what I planned on doing to disable this second rotor is to just remove it completely and block whatever oil galleys are present so it's not spraying oil all over the place. I thought that was going to be a good idea, but we consulted our Rotary sensei, and he advised against that because that would, I just clocked the gears on that would totally throw off the balance of the engine because the eccentric shaft and the two rotors are designed to be in balance with each other, and if I just removed one, it would probably vibrate. So with this second inactive rotor being in place, we have the issue of compression that Mark realized. We consulted our rotary guru once more, and he advised us to just remove the apex seals. It won't generate any compression, and we won't lose torque. We still have the extra inertia from the rotor that we have to move as it goes, but there's nothing that can be done about that because that very inertia is what's keeping the system in balance. So as crushed as I am personally that we're not going to be cutting into stuff and taking it beyond the point of repair, we made pretty good progress today, knowledge-wise. We have a direction to go, and being as we don't have to do this, there's no mistakes that can be made. And we'll have a working engine with a electric motor, doing electric motor stuff sooner than we would have if we started, butchering this thing to all get out.
So you could have the engine running without the electric motor. Just running on the single cylinder.
Exactly. Yeah. I can put this back together, install it in the car, and get it running, and then see what kind of electric motor we're going to use. So I guess all there is left to do is load this stuff back up and start putting it together at home.
Yeah.
Smart freaking guy that Mark is. We are eliminating non-essential experiments so that we can focus on essential experiments. It's a darn good thing guys like him are on the team, because if it's just up to me, I'm like, cut it off, see if it still works. So yeah, that one-day trip out to Arizona, even though we didn't cut anything, might have saved us months of wasted effort. Thank you, Mark. Thank you, Akihi. I'm sorry for saying your name wrong. I'm trying my best here. So in order for me to write legibly, I have to write terribly slow. So I'm just going to skip forward to when I have things on this board that we can look at. Miata dudes, I have some good news on the intake system development. A dude reached out to me by the name of Blake McConaughey, who's a Miata enthusiast, in addition to wanting to support Project OSAKI that we're working on right now. And him and I are going to be putting our heads together to figure out what we need to do to test this Miata intake system and get it completed and ready to download or purchase or whatever the case may be. And on top of that, he's a really awesome dude that sells custom Miata products on his website, McConaughey Performance. I've attached a link down in the video description below, so go check out his stuff if you have a Miata and help support this project and his business. So as you can see, my words aren't all that much more legible if I do take my time, but I think we'll be able to read it. So we have a bona fide to-do list and a direction to go now. First, we pull the blown engine out of the Mercedes. There's a fun fact about that engine. So when that thing exploded, threw a rod through the oil pan, leaked oil all over the ground, that thing was still running when I pulled it over. It was sitting shaking itself to pieces, and I had to shut it off manually so that it could finally have its final resting place. So if that story is not a testament to Mercedes diesel engine robustness, I don't know what is. So we pull that junk out of there, and then we can start assembling our 6A rotary peripheral port engine with one dead rotor. We're going to take the apex seals, as I already said, out of the dead rotor so it's not producing compression as it spins. We have to make manifolds because now we have a peripheral port. The exhaust manifold's super big and heavy and ugly, so we'll need to make two new ones. The exhaust will need a O2 sensor because we're going to fuel injection. Then we'll need a fuel injector port for the intake side as well. A lot of people are under the impression that a peripheral port won't run well at low RPM. And I believe you're under that impression because generally when you go to peripheral port, you put a big old huge intake diameter on that port. The reason for doing this is usually for racing. And for racing, you want all your performance at the top end. The thing is, the port doesn't have to be that big. You can restrict the diameter so it can still operate well at low RPM and mid RPMs. But this isn't going to be a race engine, so we can restrict that diameter a little bit. It'll still have good chamber filling at low and mid RPM, and I expect if we do a little bit of math and flow analysis, it'll still operate well at low RPM. Plus, we're going to have an electric motor that's assisting it at low RPM, so I think it'll be a nice little combination. Sourcing the ECU will be challenging. I don't know if there's any off-the-shelf ECUs that are programmed to run single rotor Wankel engines, so that might be a bit of difficulty. We might have to do some custom stuff. I don't really know. That'll be challenging. It'll also be fun. So seals and bearings. Last time this engine was taken apart, which, you know, this engine's only run maybe 2-3 hours since the seals were changed. So those apex seals and side seals should be pretty fresh. The only thing I don't know is if you change the orientation of them or if you change them from one corner to the other, if you're going to create a catastrophic wear pattern in the housing. I'm not really sure. It might be worth it to change the seals, except that I can't really afford to change the seals right now. So my options are to put it back the way it is, which is probably fine. The only thing I don't know is if the bearings are fresh. So that's a question. They don't look very fresh. So changing the bearings at a minimum would probably be a good idea, or putting it all back together the way it is. The other option is if any of you watching have access to some apex seals that you might be willing to donate to the cause, I would be greatly appreciative of that. And it would really help, like, peace of mind with putting this thing together and knowing that it's going to work and run properly. So I'd be beyond appreciative if any of you had access to some seals that you'd like to donate. It'd make a huge difference for us. After seals and bearings, we just install the thing with the transmission. We're just using the factory transmission. That thing's still good. I'll probably put a new clutch disc on it, put that back in the car, and then we can install a motor on the nose of the eccentric shaft to help it be more efficient. So the interesting thing about the motor is we want to time the pulses based on the angle of the rotor in the engine. So I don't know if we can make an off-the-shelf electric motor control system do that, if it can speak to the sensor on the engine ECU, you know, the one that's getting the reading off of the trigger wheel to know where the engine is. I don't know if they can talk to each other that way. So the control system between the electric motor and the ECU is going to be, like I said here, probably one of the most challenging components, but probably one of the most fun too. So on the motor, I wanted to use a golf cart motor, like a powerful golf cart motor. I was hoping for at least 30 horsepower, but that's just a little bit beyond what most of the even most powerful golf cart motors produce. Maybe they can in short intervals with enough amperage, but then we're limited by the battery pack, which is something I forgot to write on here. Which leads me to my point of wanting to use a golf cart motor is they're designed for a 48 volt architecture normally, which is a nice safe architecture. I think perfect for a DIY project just because it's much less lethal to make your own battery pack or do DIY stuff with lower voltages than it is to do it with higher voltages. When you're working with 600 volts DC, or anything over 200 volts, it's a little sketchy. So any time spent learning how to make low voltage systems do what we want them to do and perform well, I think is time well spent. That's not to say that the only 48 volt motors are golf cart motors. There might be something a little bit more powerful that works with low voltage that we'll find, but you know, cost is a big factor as well. So once that's done, all that's left to do is get all the old diesel out of there and fill it with gas. Rotary engines run on pretty low octane fuel, so I'm not too concerned about like residual diesel on the walls, like having to scrub it all out or anything like that. If it was a high performance engine that ran on high octane, definitely I wouldn't want any diesel in there at all. But this engine runs on premix, for goodness sake. I think a little bit of diesel left over probably won't do much harm. I think it'll just chew it up and spit it out. So yeah, this is really exciting stuff, guys. So many of you have reached out. I was overwhelmed. I did not expect this much success from the first video. I published the first Project OSAKI video a month ago, and my initial plan was to publish another full-length video maybe a week or maybe 2 weeks after that, but that video had so much success and I had so many people to reach out to and put in the Discord channel as developers and developers to talk to inside of the Discord channel and all of this planning and organizing to do around the project itself to make sure that it's healthy and that as it moves forward, it doesn't get chaotic and kind of, segmented and break off and us lose focus on what the goals are. There's been so much going on behind the scenes, it's taken this long to produce the second video, but as more big brains, bigger than mine, come into the project to help me keep everything organized, I should be able to publish on a better schedule going forward. But man, you guys are awesome. You guys are so cool. In the comments too, there's been so much interaction from the first video, and I thank you, thank you from the bottom of my heart. This is awesome. This is really cool. If you want to be on the Discord channel as a developer, it's public now. You can go down on the link, you can click it, you can join in, view everything we're talking about. But if you want to be a developer on the project, check out my website where you can submit a form. In that form, you're going to get a questionnaire emailed out to you, and then fill out the questionnaire so that we can learn a little bit about you, have some data to talk about when we schedule our call. And then either myself or one of the team members that's responsible for the specific arm of the project that you might have experience or expertise in will reach out to you, have a personal call. Don't think of it like an interview. It's really chill. We're just trying to get to know each other, satisfy your curiosities. If you have some questions about the project that you want answered, we'll be there to answer those questions. Then we'll put you into the server as a developer, and then you can contribute to all the different channels that are in there. I kind of split up my content strategy recently, so all of the short form content is now going to live on Instagram because it gives me a little bit more time to provide information. YouTube Shorts are limited to 60 seconds, and there's only so much you can say in 60 seconds. So if you want more regular, smaller updates, head on over to Instagram under Stand Racing, and all of my long form content is going to live here on YouTube. And you know where to find me. So stay tuned for the next video where we're going to be pulling that engine out, putting this engine together, and seeing what we learn about our control systems. See you there.